Welcome to Unit 8, Part 2. We are going to start with 8.4, Day 1 notes, which is solving quadratic equations by factoring. Before we begin, though, let's go ahead and review how to factor from Unit 7. The first part we're going to do is factoring of the greatest common factor, factoring by the GCF. So let's go ahead and look at this first box, Part A. What you recognize is you need to first recognize what number can go into both 26 and 13, which is 13. 13 times 2 is 26. From here, let's look at the x's. Remember, we choose the smallest exponent. So between x to the fifth and x squared, we choose x to the second power, so x squared. Same thing to the y's. Y to the first, y cubed, we choose y to the first. 13x plus y is my GCF, so again, that's going to come out in front. Now, to figure out my leftovers, we divide. Alright, 26 divided by 13 is 2. X to the fifth divided by x squared. Remember, we subtract our exponents. The numerator has 3 more x's because I do 5 minus 2. So it turns to a 3. X cubed. And lastly, look, there's a tie with the y, so there's no more y's left. Minus 13 divided by 13 is 1. Look, I have x squared divided by x squared, that's a tie, so there's no more x's. And I have y cubed and y to the first. The numerator wins by 2, so y squared. Generally, you don't need that 1 there, but just so you know that it's the negative 1. We'll leave it there. Alright, let's go down. Then we move on to factoring trinomials, and the leading coefficient is 1. Again, you still always check for a GCF, but if you look at Part C, there's not a single number that can be divisible by all 3 terms. We're going to start by writing what makes x squared. What 2 things multiply x squared? That is x and x. Now we're going to write down all of the factors of negative 36. Remember, to make a negative number, it will be a positive times a negative. So let's start. Negative 1 and 36. Negative 2 and 18. Negative 3 and 13, negative 4 and 9, negative 6 and 6. Now, out of all these combinations, we're trying to figure out which combination adds negative 5. You recognize, look, negative 4 plus 9, that equals positive 5. I don't want positive 5, I'm supposed to get negative 5, so that's an easy fix. See, the negative is with the 4. Put it with the 9. Now it becomes negative 5. So those are the correct numbers for my combination. There's going to be x plus 4 and x minus 9. Alright, let's move on to factoring trinomials when the leading coefficient isn't 1. These are just a little bit harder because unlike Part C, see how we can see the combination right away? In Part D, we won't be able to know what combination works until we check our inners and outers. So again, no matter what type of factoring we're doing, we check for a GCF. So let's look at 5x squared, 18x, positive 9. If you recognize, I cannot divide one number by all 3. So again, let's go ahead and break up. The factors of 5x squared are going to be 5x and x. Now I'm going to write down all the factors of positive 9. That's 1 and 9, 3 and 3. Now, I don't know which combination is going to be. No matter what, when I check my inners and outers, it has to add 18. I'm going to put 5x first, then the x second. Let's go ahead and try 1 and 9. So let's put positive 1 and positive 9. Again, I do not know if this is the correct combination until I multiply my inners and outers. So my inners multiply to 1 times x, well that's 1x. My outers multiply 5x times 9, that's 45x. Now what you do is you add them together, that equals 46x. Well, that's not really close because I want 18. Now before you move on to 3 and 3, what you need to do is flip-flop the 1 and 9. Alright, so let's start over. Hopefully you're working with a pencil. So let's try 9 and 1. Alright, again, same process, inners and outers. My inners, 9x, multiply to 9x. My outers, multiply to 5x. When you add those together, oh, check it out, you get 14x, which is the correct answer. So 1 and 9 is the top combination, so that is how we factor part C. And then let's go up to part B, difference of two perfect squares. So our perfect squares are, the 1 squared is 1. 1 is the first perfect square. 2 squared is 4. What is the next perfect square? 3 squared is 9. That's the third perfect square. 4 squared is 16. That's the fifth perfect square. 5 squared is 625. And that's the fifth perfect square, and so on. So in part B, we're dealing with the difference of two perfect squares. If you recognize 4 is a perfect square, so I'm going to break it up as 2x, 2x. And then 121 is a perfect square because 11 squared is 121. So since it's 11 squared, I'm going to break it up 11 and negative 11. The reason why the two x's are both positive because it makes a positive 4x squared. One of the 11s is negative because I multiplied to negative 21. From here, those are my factors, 2x plus 11 and 2x minus 11. All right, so all of that information will definitely help us for our actual notes for today. So let's move on. What we're going to do is talk about what it means to be the zero product property. Basically, what that property is if you multiply a number by 0, what do you get? 0. So what A and B are just going to be any number. So if A times B is equal to 0, well, what do we know about A and B? We know either A is equal to 0 or B is equal to 0. Could both of them equal 0? Yes, because 0 and 0 times 0 is still 0. Or A and B are equal to 0. That's the zero product property. What we're going to do is we're going to solve the following equation using that property. So if you notice, look at number 1. You see how I already factored it for you? Okay? Just keep that in mind. It's already factored. It's into the two binomials. If I have x minus 4 times x plus 6, when you multiply those two binomials together, you're going to get 0. Well, what do I know? Either the first one, so let's say this is A, either A is equal to 0, or B is equal to 0, or both of them. So let's set up my two equations. We either know my first binomial, x minus 4, is equal to 0, or I know my second binomial, x plus 6, is equal to 0. So I just have two linear equations, so I'm going to go ahead and add 4 to the first side. So x is equal to 4. That's one of my solutions. And subtract 6 to both sides, so x is equal to negative 6. So my two solutions are going to be negative 6 and 4. Okay? All right, number 2. Again, look at number 2. They're already factored. Okay? So I have 2x minus 3 times x minus 4. When I multiply those two binomials together, I'm going to get 0. So by the zero product property, it's either A is 0, or B is 0, or both of them are 0. That's how I got it. So either 2x minus 3 is equal to 0, x minus 4 is equal to 0. So I have two linear equations. Go ahead and solve for x. Here I'm going to add 3 to both sides. So I have 2x is equal to 3. Then I'm going to go ahead and divide by 2. So x is going to equal 3 over 2. That's my first solution. And then my second solution, I'm going to add 4. So x is going to equal positive 4. So my two solutions are 3 over 2, comma 4. And if you notice, I'm putting them from least to greatest. The smallest number comes first, comma the bigger number. All right. If you look at number 3, you notice I don't have a binomial. I have a monomial times a binomial. If you recognize, look, that was a GCF, so both of them had an x, so I factored out x. That's how I factored 3 to begin with. So I have x times 4x minus 9 is equal to 0. Well, if I set the first term equal to 0, can x equal 0? Is 0 a number? Hopefully you're saying yes. Yes, you can have x equal to 0. this one's actually really easy because you don't have to solve. On the other factor, I either have 9 equal to 0. Now this equation we actually solve. Okay, every 9 you have 4x equal to 9. Divide both by 4. X is going to equal 9 over 4. Our two solutions are 0, 9 over 4. All right, moving on to number 4. If you recognize, look, there is a number on the outside of the two parentheses. That means I was able to pull out a DCF and then factor my leftovers. Again, I have 3 times x plus 5 times 5x minus 1 equals 0. Now, what about, if I said 3 equals to 0, does that make any sense? Oh, because 3 equals 3. So when you just have a number out in front as a number DCF, you're just going to ignore it. As opposed to look at 3, you had a variable. You're always going to set the variables equal to 0. If it's just a number, you're going to ignore it. So you're going to ignore the 3. You're going to set x plus 5 is equal to 0. You're going to set 5x minus 1 equal to 0. Solve for both equations. Here, this is pretty simple. Subtract 5 from both sides. X equals negative 5. Here, you're going to add 1 to both sides. You have 5x is equal to 1. Divide by 5. X is going to equal 1/5. Again, you're going to put them in order. My two solutions are negative 5 and 1/5. All right, what I want you to do is please go ahead and pause the video and complete number 5 and 6 for me. All right, so for number 5, remember, look, I pulled out a 10. But again, look, 10 does not have a variable attached to it, so we're just going to ignore the 10. What I'm only going to set equal to 0 is x plus 7. 7 both sides, x is equal to negative 7. That's my only solution. Now in 6, you notice 3x has a variable attached to it. So I am going to set to 0. So how do I solve x here? How do I get rid of the 3? I get rid of the 3 by dividing by 3. X equals 0 divided by 3 is just 0. And again, I'm going to set 6x plus 1 is equal to 0. Subtract 1 to both sides. 6x equals negative 1. And lastly, divide both sides by 6. X is going to equal negative 1/6. So my two solutions are going to be negative 1/6 and 0. Before we flip to the back side of the notes, do you recognize that all the problems 1 through 6, can you tell that they're already factored? So can you guess what we're going to be doing on the back side? We're going to have to factor first to get it into this form and then set both factors equal to 0. All right, let's go ahead and practice this. Okay. If you notice, look at 7. See how it's now in factored form? You're going to have to factor it first and then use that 0 product property. Okay. Again, same rules apply with factoring. Always check for a GCF first. If you notice, look on the left side. There's not a number that can be divided by all 3 terms. Let's start. The factors of x squared are x and x. The factors of negative 45. Remember, it's negative 45, so each combination will have a negative number. Negative 1, 45. Let's see, negative, we'll have 5 and 9. And we're looking for the combination that adds to positive 4. So if you recognize, look, negative 5 plus 9, that equals positive 4, so that's my combination. Now I don't need to check my inners and outers because it's just an x and an x. If it was a 2x and x or 3x and x, then I would have to check my inners and outers. So I'm going to factor the left-hand side. It's x minus 5 is x plus 9. Don't forget to drop down this equal sign because we're solving, not just factoring. All right, so now we're going to continue what we've done on the front side. I have x minus 5 times x plus 9. When I multiply those two binomials together, I'm going to get 0. So by that 0 product property, I know either x minus 5 is equal to 0, and x plus 9 is equal to 0. Solve for both equations. Add 5 to both sides, x is going to equal 5. Here, subtract 9 to both sides, x equals negative 9. My two solutions are negative 9, 5. All right, let's skip to number 8. Again, no matter what, always check for a GCF, and you should recognize that the right-hand side is not factored, so I need to factor the right-hand side. Hopefully you recognize that 121 is 11 squares. This is the difference of two perfect squares. But I'm going to drop down the zeros right away. That's generally the biggest mistake, and you will be knocked off points on past quizzes if you do not drop down the equal 0. Here I'm going to break up my factors of x squared or x to x. And since 11 squared is 121, I'm going to break it up as 11 and negative 11. So my factors are going to be x plus 11 and x minus 11. But here, I know x plus 11 times x minus 11 is equal to 0. So therefore, I know that the 0 product must be that either x plus 11 is 0 or x minus 11 is 0. So I can solve, so subtract 11 to both sides, so x negative 11. The equation x 11 to both sides, x is equal to 11. Here, I have x is going to equal negative 11 and positive 11. You also can write it this plus and minus 11. Let's have both answers, but you don't need to write both different forms. You either write negative 11 comma 11 or plus or minus 11. All right, let's continue. Let's go to number 10. Again, if you notice, the right-hand side is not factored, so I have to factor it first. First thing, drop down that equals 0. All right, let's factor the right-hand side. No matter what, the first rule is always check for GCF. If you recognize, look, every term is divisible by 2. So I'm going to divide everything by 2. I'm going to bring that down. What am I left with? M squared times 10m minus 24. From here, you should always check to see if you can factor your leftovers. So m squared, my factors are m and m. And I'm looking for factors of negative 24 that I'm going to add to negative 10. So remember, numbers that multiply to a negative number, one's positive, one's negative. So let's look. Negative 1, 24. Negative 2, and 12. So I'm going to stop right there because look, negative 2 plus 12 is positive 10. But I don't want positive 10, I want negative 10. But again, that's an easy fix. Flip the signs. So I drop down the equal 0, and don't forget to drop down the 2. My factors are going to be m plus 2, m minus 12. All right. So, do you remember what to do with the 2? Ignore it or set it equal to 0. If you're unsure, just look. Set it equal to 0. Does that make sense? Does 2 equal 0? No. Because it doesn't have a variable, we're going to ignore it. We're just going to set m plus 2 is equal to 0 and m minus 12 is equal to 0. Here, by subtracting 2 to both sides, the first solution is m equals negative 2, and adding 12 to both sides, m is 12. So my two solutions are negative 2 and 12. All right, let's skip back. Let's go to number 11. Again, you should recognize that 11 is a factor. So you have to factor the left-hand side. Always check for GCF, and you should recognize both terms are divisible by an x. So I'm going to divide both by an x and leave it out in front. I'm left with an x minus 7 is equal to 0. Now, I have x times x minus 7 is equal to 0. Since there's an x out here, I am going to set it equal to 0 because 0 can equal to x and 0 is a number. Right? And then I'm going to set x minus 7 is equal to 0. Add 7 to both sides, x equals 7. My two solutions are 0, 7. Again, if it has a variable, has a letter, set it equal to 0. That's why I set x equal to 0. If it doesn't have a variable like that too, ignore it. All right, move on to number 12. All right, so again, the left-hand side needs to be factored. There's no GCF, so I'm going to go ahead and start factor with x squared or x factor 5 or 1 and 5. But do you see there, the only thing that makes 5 is 1 and 5 and negative 1 and negative 5, and none of those add to positive 7. So this equation cannot be solved by factoring. We are going to learn next week how to solve this equation. It's called the quadratic formula. It's a formula that we'll be able to solve for x here. Okay? So if you can't factor it, don't worry. It just cannot be factored. Solved by factoring. Okay. Let's go ahead and do number 13. Again, the left-hand side needs to be factored. You should always check for a GCF first. Do you recognize a number that I can divide both 6x squared, negative 15x, and negative 9 by? Hopefully you're saying 3. So I'm going to divide everything by 3. Bring down the 3 in front. I'm left with 2x squared minus 5x minus 3 is equal to 0. Right? Always check to see if you can factor even further. So I have 2x and x are the factors of 2x squared, and everything that makes negative 3 is negative 1 and 3. Do not forget to bring down the GCF, which was a 3. Now, since this is a 2x and an x, I don't know what the correct combination is, meaning what order. Does negative 1 come first or 3? So I have to check my inners and outers to verify that. So 2x first, x second. Let's go ahead and try negative 3 and positive 1. Yeah, I don't know if that's right, so let's check. 1 times x, that's 1x. 2 times negative 3, let me scroll down, is negative 6x. When I add those two together, I get negative 5x, which is exactly what I wanted. Do not forget to drop down that equals 0. From here, I have to set 2x plus 1 equal to 0 and x minus 3 equal to 0. Hopefully you understand why we do not set 3 equal to 0 since there is no variable. So we're going to set 2x plus 1 is equal to 0, and then we're going to set x minus 3 is equal to 0. From here, subtract to both sides. 2x is equal to negative 1. Divide by 2, x is going to equal negative 1 half. The other equation, we're going to add 3. X is going to equal positive 3. So my solutions are going to be negative 1 half, comma 3. All right, last question. Number 14 was right. Again, if you recognize the right-hand side is not factored, so we're going to go ahead and have to factor it. Same rule of thumb. Check for GCF first. Let's go ahead and drop down to 0. You recognize both are divisible by 9. You're going to divide by 9 and left with x squared minus 9. Always check to see if you can factor your leftovers. Hopefully you recognize that 3 squared is equal to 9, so this is a difference of 2 perfect squares. So drop down the 0 equals drop down the 9. Factors of x squared is x and x. Factors of negative 9, well, since it's a perfect square, I'm going to go 3 and negative 3. All right, so my factors are going to be x plus 3 and x minus 3. So here we're going to write your equations and set them equal to 0. Hopefully you know this by now that we are going to ignore this 9 since there's no variable attached to it. I'm just going to set x plus 3 is equal to 0 and x minus 3 is equal to 0. From here, subtract 3 to both sides. X equals negative 3 and x equals positive 3. So my two solutions, again, you can write it as negative 3 comma 3 or plus or minus 3. I will accept both answers. Do you recognize a commonality between all these questions on this back side? I want you to look, highlight, look. equals 0, equals 0, equals 0, equals 0. You should recognize that every equation is set equal to 0. So look, in this challenge question, is it set equal to 0? No. So that's what we're going to be adding in the next video. We're going to add one more step and get the variable equal to 0 first. So we'll use our knowledge from Unit 1 in getting moving terms from the left and the right. So since this is a 2x squared and it's my quadratic term, I'm always going to want my quadratic term positive. So I'm going to move the negative x over by adding x to both sides. And I'm going to move the 3 over by subtracting 3. Now none of this I can combine, because one is an x squared, one's an x, and one's a negative 3. So I'm going to write it in special order, number standard form. So 2x squared plus x minus 3, drop down the equal sign. What's left? Equal to 0. From here, we're going to continue the same steps that we've been doing. All right, go ahead and stop the video and complete your homework.